this topic, we'll discuss about geometry, and let's start our discussion from the coordinate plane. Now, so we'll be discussing about the rectangular coordinate plane specifically in this topic. So it's made up of two number lines crossing orthogonally, and the point of crossing is called the origin. The horizontal axis is commonly termed as the x-axis, and the vertical axis is the y-axis. Okay. Another important point, the plane made up of these two lines has regions to it, and these regions are called quadrants, and this is called first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. Okay. So their unique properties. So in the first quadrant, all points in the first quadrant are positive. So let's take a given point, an arbitrary point. Point A, coordinate point x, let's say 1, y, 1. All points in this first quadrant are made up of positive value for x and positive value for y. So the x values in all quadrants, so the first entry are called, the x entries are called abscissa, and the y coordinates are called ordinate. Okay, so the abscissa is always positive and the ordinate is always positive in the first quadrant. Okay, so this is the second quadrant. In the second quadrant, again, let's assume some point here. Let's call this point B, and let's have now x2, y2. Okay, so in the second quadrant, as you see from here, x values are always negative and y values are always positive. Okay, so we have all x coordinates negative and all y coordinates positive. Okay, in the third quadrant, let's take a point, any point here. Let's call it C. So the coordinates are x3, y3. So this pair of x3, y3 are the coordinates of point C. Okay, and as you see, x values are always negative and the y values are also negative. So we have negative x entry and negative y entry in the third quadrant. Okay, and the last quadrant is the fourth quadrant. So in the fourth quadrant, again, let's assume a point here. So let's call that point D, and the coordinates for that point are, let's call them x4, y4. So x values are positive and y values are negative. We'll always refer first x values and then refer y values here in the same way. So x values are positive and y values are negative. Okay, now let's identify some pair of coordinate numbers for some points, and let's identify them as being whether they are in the first quadrant, second quadrant, or the fourth quadrant. We'll always refer the first entry of the pairs to come from the x-axis and the second to come from the y-axis. So in our example, point, okay, and quadrant. So let's have 0, 0. So which quadrant is 0, 0? 0, 0 is x0 and y0. Okay, so x0, y0 is the origin. So this is none of the four quadrants, but this is the unique condition where this point is the origin. So this is the, we call this origin. So 0, 0 at point there, 0, 0 is the origin point. Example 2, 0, 4. We can draw another coordinate plane here. 0, 4 point in our plane. This is x and y. So our x-axis is 0, so it's none of these points on the x-axis but 0. The y-coordinate is 4, so that point there, this point here, is the 0, 4 point. Okay, so it actually is on none of the quadrants, but it's on the y-axis, on positive y-axis. Okay, so example 3, let's have 4, 0. 4, 0, now x in 3 is 4, y in 3 is 0, so it's not up or down of the x-axis, is just on this point. At that point, y is 0. Okay, so at point there is 4, 0, and mind you that was 0, 4. So our 4, 0 is on positive x-axis. Okay, all right. So 4, 0, minus 3. Again, x in 3 is 0 on the x-axis. Here it's 0. Okay, and the y in 3 is minus 3. So it's this point here. That point is it's x in 3 is 0 and y is minus 3. Okay, so this is again on none of the quadrants, but on negative y-axis. So this point is on negative y-axis. Okay, example 5. Let's take minus 3, 0. Minus 3, now this is x in 3, so x is minus 3, y is 0. Again, that point y is 0. If you go up any point, y will be positive, different from 0, and if you go downwards, y will be negative, which is different from 0 again. But at this point, y is 0, so we have that coordinate here, minus 3, 0. Okay, so again, this is also on none of the quadrants, but on negative x-axis. Okay, so let's continue with our example 6. Point, let's take coordinates 3, 4. Okay, now its x in 3 is 3 and its y in 3 is 4. So x3, y is now different from 0 but positive, so we go up here. So x is 3, so for y we go up and we have 4 here. So that intersection point, that point is 3, 4. So that's our point 3, 4. So our point 3, 4 is in the first quadrant. Okay, example 7. Let's take minus 3, 4. Now I see the x in 3 is minus 3 here, while the y in 3 is positive 4. Okay, y is in 3 is positive 4, we go upwards for y. So that point is minus 3, x in 3 is minus 3 and y is 4. So our coordinate here is minus 3, 4, which is in the second quadrant. This is in second quadrant. Okay, let's give another example. Minus 2, minus 3. So minus 2, minus 3, x in 3 is minus 2, y in 3 is minus 3. So let's check minus 2, then for minus 3 again we go downwards to get y, so that is the y entry, so which is -2 -3. So we'll always refer the x value first and the y entry next. So that is -2 -3. So that point here is -2 -3. Okay, so that point is in the third quadrant. So in third quadrant. Okay, so example 9, let's have 3 - 4. X entry is 3 and y entry is 4. So x is 3, it's that point here, and y is -4. For -4 you go down, and that's -4, and that point here, the intersection of the two, is this 3 - 4 point, which is in the fourth quadrant. Okay, so this is in fourth quadrant. All right. Then the next point that we will discuss in the study of coordinate plane is lines. Now, given there is a coordinate plane, so there are different type of lines. One is the horizontal line. Horizontal line can be defined as follows. In a horizontal line, we have fixed y value for different value of x. An example could be y equals 4, y equals -1/2, y equals 0. So these are examples of horizontal line. So let's just put these lines in this plane. Okay, now the first example is y equals -4, so that horizontal line is 4 is positive value, so y will have a constant positive value like that. So that's our first horizontal line. Okay, and it continues indefinitely. Y equals 4. So on this line the value of y is unchanged, so regardless of x, the value of y remains the same. That's always 4. On this level the value of y is always 4. The example is y equals -1/2. So this is a negative value halfway between 0 and 1. So again, same way, that extends indefinitely. So that point here is, let's say that's -1/2. So as you see, x is changing indefinitely, but the value of y remains the same. That point is -1/2. Okay, so let's have another. So the last example is y equals 0. So whatever the value of x, so y would not change. If you think about it, y equals 0 passes through this origin, okay, and y will always be 0. So therefore we're talking about the x-axis. So that horizontal axis, the x-axis itself, is a horizontal axis defined by the equation y equals 0. So for all values of x, there is no change in y on that x-axis. Y will always be 0 throughout. Okay, so a unique condition of horizontal axis is the y equals to 0 axis, which is the x-axis. Okay, y equals to 0 is the x-axis. Okay, so that's something you need to appreciate. It might come handy in the future. Yeah, Second type of line is the vertical line, as you would now expect. So vertical line, we have a fixed x value for different value of y. So if the y value changes, the x value remains the same. Okay, so fixed x value for different y value. Okay, so for different y value. We can take again an example here. We will fix x as opposed to fixing y, as we have seen in the horizontal line case, but in this case we fix x to be some value. Example, x equals 3, x equals minus 3 over 2, x equals 0. So let's see these three cases. First case, x equals 3. Now the x value is now fixed. Okay, so we're talking about this line. Okay, so that also extends indefinitely, passing through x equals to x. So that is where x equals 3. Okay, x equals 3. Now as you see, on this line, x value is fixed. So if you go to this point, x equals 3, this point, x equals 3, down here, this point, x equals 3. At this point, x equals 3, but the value of y is varying. Okay, but in all cases, the value of x remains the same, which is 3. So in the same way, the second example, x equals minus 3 over 2, which is halfway between minus 1 and so it must be this line here. Yeah, okay, so that point there is x equals minus 3 over 2. Okay, so the same way, on this line, the value of y is varying. Okay, but the value of x is always minus 3 over 2. And the last one is x equals 0. Again, now, so x equals 0 is this point here at the origin. Now the vertical line that passes through that point is the y-axis. Okay, so the y-axis is also unique condition of a vertical line that passes through the origin. So x equals 0 is nothing but the y-axis. Okay, so we can also put this to back of our minds for the future use. Note that x equals 0 is actually the y-axis. Okay. Okay, the other type of line is the slant line. So slant lines are neither vertical nor horizontal, and we'll see two types of these slant lines. Example 1. Let's take a slant line that passes through the following coordinates: minus 1, 0, and 0, 2. So this is one example. So let's check this line that passes through minus 1, 0, and 0, 2. Okay. So first let's just find these coordinates. So minus 1 stands for x and 0 stands for y. So definitely we know that this is on the x-axis. Okay, so that is minus 1, 0 here. That is minus 1, 0 is that point here. In between that and 0, 2. So 0, 2 is a point on y-axis because x is 0 here. So it's that point here. So we're looking at a line that passes through these 2 points. All right. Let's just make an attempt drawing this line. Okay, so that line is this line that passes through these two given points, -1, 0, and 0, 2. So okay, example 2, lines through lines through 0, 2 and 3, 0. Now by complete coincidence we have another point 0, 2, but that point is the same point again, which is the same point again here. Okay, that is 0, 2 and 3, 0. 3, 0 is a point on the x-axis, which is x is fixed, y is 0, so x is 3. That is that point there. Okay, so we're looking at a line that connects these 2 points. We have that point here is 3, 0. Okay, so again we'll be attempting to draw a line that connects these 2 points. Okay, all right, yeah, fine. So we have that line that passes through 0, 2 and 3, 0. And these two, the difference between again this line and the previous line, slant line, they're both slant lines, but in the case of this example, as you go from left to right, the line actually goes down. But in this one, as you go to left to right, the line actually goes up. And we call this gradients, and while line 1 has a positive gradient, which is increasing y for change in x from left to right, but our example 2 has a negative gradient, which is decreasing y for change in x from left to right. Okay, so we'll be discussing these points in the next topics. So lines have some properties again. They have something called x-intercept. So an x-intercept is a point on x-axis where the line passes through. Okay, so a point on x-axis where the line actually crosses through. So the intersection point between that line and the x-axis. So on x-axis, what is the value of y? An interesting point here is that y equals 0. Okay. Another terminology, y intercept, an intersection point between the line and y-axis. Okay. So between the line and y-axis. So on y-axis, every x point is 0. X equals 0. So okay. So in the same way, we should understand that y is equals to 0 is not an intercept, but is the value of y at that point. Okay. So this is the value of y coordinates, okay, at x-intercept. So as we have discussed, one additional point is the gradient. This is also referred to as the slope. So the slope of a line is how steep a line is. Okay, how steep a line is. This can have positive or negative value. Okay, in the case of our example here, our line was going up, so it has positive value. In the case of example here, it was going down as x increases. If an increase on x results in increase in y, we'll have positive gradient. Okay, but if increase in x results in decrease in y, we have negative gradient. So the gradient, also called the slope, is designated by small letter m. So this is defined as change in y per change in x. Okay.
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment, and subscribe, and don't forget to click the notification bell.